Hello, I'm Lal Paul. I'm working as the system administrator of Cochin University of Science and Technology. In this presentation, I would like to say something about Cochin University campus networking, how the history of internet in the campus. Okay. So to begin with, I would today say something about the, the email facility which was first launched in the Cochin University. So in 1991, we had a system from an email server from NCST Pune. So the server was hosted in Pune NCST, and we have to use a Linux operating system to download the mails which is stored in the server in Pune. So using Unix to Unix communication protocol UUCP, we used to fetch the mails. So at that time, only say nearly 10 users were using the email facility, and the email address starts with the jin.airnet.in. So for getting the mails, we have to use an STD dial-up to using a modem, the usual modem, and we have to download the mail. So it will be costly. So we'll be, and as I told you, so there are nearly only 10 users in the using the mail. So we need only say once in a week to get the download the mail. So during 1994, Cochin Ernakulam city uh, launched the dial-up connection. So there were two types of dial-up connection. One was the shell connection, and the other one was the TCP connection. So we purchased a TCP connection. So TCP connection means the interface will be using our normal graphical user interface, and whereas in the shell connection, we don't have any graphical user interface. We have to use the command line. So we purchased a graphical user interface, that is the TCP connection. TCP means transmission control protocol. And apart from the STD connection, we only need to dial in the local number. So that the internet service provider at the time was VSNL, that is VS Vidar Sanchar Nigam Limited. So we have to dial. The office was in the Kakanada. So we have to dial uh, using our dial-up connection and using a modem, normal modem, to get connected. And during that time, Netscape was the common browser we used, and Yahoo.com was the search engine we were using. And at the time, we had as a few MTech students, and we need to share. Only our staff members were using the internet at that time, but we want to share the internet to the students doing MTech in our department. So using a software called Wingate, we shared the network. So for that, we need an IP address. IP address, what is an IP address? Will be coming to that. At that time, we don't have any website. So, but later, CUSAT.edu was purchased, and we uploaded some text files using an HTML. And at that time, but there was no graphic, website editor, web page editor. So we have to write our own HTML tags to get our pages. Now, after some years, we got a financial aid from the Dutch government. Netherlands University, that is Delft University, gave us some financial support. And using that financial support, we laid a fiber optic cable throughout the campus. And of course, you know that we have a campus in the Cochin city. Sorry. And there also this fiber optic cable was laid. And those people, the deaf people, uh, need to install all the web servers or all the network servers using the Windows platform, Microsoft platform. So we had IIS, Internet Information Servers, which is a Microsoft-based web server, the DNS server, proxy server, mail server, etc. Everything was using the Microsoft. And at that time, we had a 64 kbps lease line. These lines mean we have only one line is dedicated to us. So 64 kbps line was installed. That was from BSNL, and the media was the microwave connection. So for the microwave connection, we need to erect two towers between the Cochin University campus and the ISP campus. That is the BSNL. So there should be a point-to-point protocol, and a line of sight should be there to get it connected. So using a microwave connection, we connected our network. So at that time, it was when starting with 64 kbps. So after say few years, 1 year or 2 years, and we increase the bandwidth like 1 Mbps, then 2 Mbps like that. So uh, after that, after this microwave connection, we used the normal telephone lines to get it connected. So after 2 Mbps, it was connected. Then let us see what is a fiber, how we done the fiber labor laying in the campus. So basically, we have three stations. One is actually in the computer center. That is for the main station where the internet connection was landed. Then we had a substation in the physics department. And the third substation was in the offshore campus, that is in the marine science campus. Okay, we had three main centers to host our network. So these are the main hub. These three are the main hub. From these hubs, different departments were connected using the fiber optic cable. Okay. The, at that time, no single mode connection was not established. So at that time, we had multi-mode connection. And using the multi-mode connection, as you know, for a multi-mode connection, we can't go further. Say maybe I don't know. I think it is say maybe up to 1 kilometer only. So we have to restrict our connection with this multi-mode fiber optic cable. So later it was converted to single mode. So to get it connected in kilometers. Okay. Now at that time we had ST connectors, XT connector to terminate our fiber optic cable. We had a six core, certain six core cables are there, then 12 core cables are there. So everything was terminated in one of the hub racks. In the hub rack, we had a patch panel. From the patch panel, we had fiber optic cable, fiber fiber optic patch code. This patch code has a ST connector patch codes, and our hub also had a fiber optic module, which is ST. So we have to connect this one. And for the LAN connection, we used Cat5e connection. So Cat5e at the time needs supports only up to 100 Mbps. And you know, as you know, it cannot go beyond 100 meters for a Cat5e cables. And to connect from computer center to lakeside, we used ISDN connection, which was a common connection between two remote campuses. We used the ISDN connection. And let us see the mail history in CUSAT. As I told earlier, we had an Ethernet connection from the Pune. And after launching this fiber optic cable in our campus, we got a license, a campus license from the Microsoft to establish our network servers. So for a mail server, we used the Exchange Server 5.5. So we started with Exchange Server 5.5. And all the faculty and students, staff were given the mail ID, and we purchased a domain as CUSAT.ac.in. Nowadays, it is actually a second level domain. Nowadays, we can have a first level domain also. At that time, we don't have a permission to get a first level domain. So this is a second level domain. CUSAT.ac.in. AC.in was provided by the NCST. Then this mail facility was extended to research and also the postgraduate community. And at that time, so to prevent the open relay of the mail server, because to fight, we were the main difficulty was to fight against the spam. So first first level spam fighting was the preventing of the open relay. So when a spammer trying to find the mail servers, what he does is he will he will check what all mail servers is open for relaying. So we have to prevent this open relay. So for that we use the prevention system that was on XWAL, Microsoft software. Then after a few years, this Exchange Server 5.5 applications were not there. They have moved to 2000. Microsoft 2000 came in, and also Exchange 2000 came in. But we don't have any license for to upgrade this one. So we thought we try this one for a trial as a trial basis. We tried this conversion upgradation of Exchange Server 5.5 to Exchange 2000, but everything gone in vain. So we don't this fight the spam filtering and everything was not much sufficient, not satisfactory. So we thought of migrating from this one to an open source. So at that time, we heard of this Qmail. Qmail was at that time it was an effective SMTP server. So MTA, message transfer agent, MTA or MTA, we use Qmail. But Qmail is actually is backend. We have to design a front end for this Qmail. Qmail also it only holds our mails, but we have to build all the mails into the user using a graphical user interface. So Squirrel Mail we choose as a front end and interface, and also the anti-spam filtering. Spam filtering was also implemented. There were so many spam filtering like spam assassin, spam host, everything was there, but it was not also success. Then we heard about this Simpra mailing solution. So and we found that Simpra is a quite good one, and that look and feel is very good, and user it is just like Google Gmail like interface was there. So we thought of migrating to Zimbra. So we converted to Zimbra Mail Server. By the way, this Microsoft mail clients they will not allow anything uh, migrate to any other MTAs at that time. So we developed a Perl script, and without affecting the mails of the users, we migrated all the users from Exchange Server to Kubernetes. It was a big success for us. So we have done it. And after my fighting with the spams, it was very difficult to fight with spam. So we thought of migrating to Gmail. So Gmail, we heard of that Gmail provides unlimited user service to education sector. like university or institutions like us. So we thought of migrating these users from Zimbra to Gmail. So we we successfully migrated all the users to Gmail. Now still we are using the same solution, right? Now let us, that is about the mail servers. Now let us see the internet history in CUSAT. So as I told you, we purchased 1 Mbps, 2 Mbps, like that, like that. So to implement an internet in a campus, first of all, we need a router. So we choose Cisco as a router. Then at that time, we don't have any firewall. And as of course, there was a firewall of our Microsoft. And after changing our system to open source, we don't have any software firewall. So we use this Cisco ACS as a firewall. So it will block the layer three filtering. Okay. So then using a Windows connection, we proxy as I told earlier, everything was connected. See, this Windows DNS server was used for DNS, and the CUSAT dot it was CUSAT dot AC dot in was registered, and it was with Herman.in, and it is education research network was there. As I told, it have they supplied only second level domain, and all the servers were hosted in Department of Computer Science, and we the staff of our computer science department was get trained from Netherlands University, and we were in charge of these servers. Okay. Then after 2001, we increased this bandwidth to 4 Mbps. At the time, we converted, as I told, we have converted all the Microsoft system to open source system. Then Red Hat 8.0 was purely an open source system. They were Red Hat Enterprise Linux was also there, but it was paid. So 8.0 was a fully open source system. So we converted all our machine to Red Hat 8.0. And IaaS was replaced with Apache server. DNS was replaced with Bind, that is Berkeley Internet Name Domain. In proxy server, we used was a squid proxy. It was a firewall, and it was a good one. And for caching, so caching purpose, it is good, is very good. Then we can filter all the users. We can set our own layer four filtering, and we can analyze the monitoring of network usage. A script analyzer was there to monitor. So using this script analyzer, we can see all the users, their IP address, what they are doing, what time they have logged in there, what the time they have logged out, and what all websites they have gone in, and everything we can list it. We can get it printed, and we can supply to what the HOD or this much facilities were there. But and at that time we used the IP tables as a firewall also. And for this for this kind of, we use the transparent squid proxy, transparent proxy server. So set this as a transparent proxy server. We had to use the IP tables as a firewall, and the netting everything was done using IP tables. Then uh, after some time, at that time, the users were only below 100. So one network was sufficient for them. One subnet was sufficient. But later, when this user increased, we have to split this subnet in the one net into different subnet. So as to reduce the collision. So we divided our network into different subnets. Bandwidth was increased to 4 Mbps. Then the new internet connection was purchased because we need a higher bandwidth demand was there. So we start off thinking getting more bandwidth from different players like Airtel, BSNL, Rail, Reliance, Power Grid, etc., etc. So we placed a quotation. We have got a good number of quotation that our aim was to increase to 8 Mbps. So Reliance were given the order. Reliance was the least quoted ISP. So Reliance were awarded the quotation for a 8 Mbps connection and also for the telephone exchange facility, TID facility as well. And internet was launched. The OFC cable was straightly coming into our campus, and we that the internet was established at that time, and a 1:1 connection was given to us. And after 1 year, we changed the ISP to BSNL since it was a government of India enterprise. We changed our private internet from in Reliance to BSNL. So we got at that now we are enjoying 250 Mbps Reliance BSNL connection, and also the voice connection was also there. And as you know, this time our new campus was also started in the Pulingun, Aluva district, and we need to connect a lease land, a land to extend our land to pulling on the campus also. So we purchased a lease line, a dedicated line from our main campus to pulling on the campus in Alabama, and we got a 40 Mbps connection. Now we got a 40 Mbps connection to pulling on the campus, and a lease line to Marine Science campus. We got a 50 Mbps lease line connection. Then, after a few years, National Knowledge Network was introduced. That was the Government of India enterprise, a project from National Informatics Center of the Government of India. And the aim was to share the lectures and seminars between the different universities and different IITs of India. So they provide us a 1 Gbps connection, and we had to deliver our lectures to all the university. So unfortunately, at that time we don't have any online facility to deliver our lectures. We had an opportunity to get um, the lectures from the different universities in India, all over India. For that, we got an 1 Gbps connection, so it was fully free. And internet was also the apart from the 1 Gbps local, WAN connection, we had an internet connection also, and I think it was some 100 Mbps, but it can be scaled up to 1 Gbps connection as per our demand. And after that, after 1 year to 1 or 2 years, Polymer Science and Paper Technology Department also had got a 50 Mbps line from the National Knowledge Network. And apart from this 1 Gbps connection, we got a 50 Mbps connection from Polymer Science also, from the NIC through Polymer Science Rubber Technology Department. Okay. By the way, this PSRT connection was maintained by the ISP Power. All the other one, uh, they NKN gave us BSNL connectivity. The physical line was BSNL connectivity. Now let us see what is a CUSAT, what we have done for the CUSAT. So likewise, any campus networks, CUSAT also maintained three zones. One was the internet zone, the demilitarized zone, and the militarized zone. For the internet zone, it is actually internet connection of the CUSAT. Then the public access service servers is launched in the demilitarized zone, that is DMZ zone. Then our actual local area network, that is in the militarized zone. And all these zones are managed by a firewall. At that time, UTM was introduced, that is Unified Threat Management Solution. That is a hard-coded machine which serves our firewall, anti-spam, antivirus, intrusion detection. Everyone was combined together to form a common one box, which is called as Unified Threat Management Box, UTM box. We got a 48 solution. Then this is our network, uh, CUSAT campus network. And you can see we have three zones. This is our internet zone. This is the internet zone. This is the DMZ zone. And this is the local area network zone. And you see, this is the internet. The internet came through three areas. One is uh, through NKN 1 Gbps connection. Then our home 250 Mbps connection. Then through the polymer science and rubber technology. Everything is launched in this firewall. Before that, we have a router, a router Cisco router here. For this, we had for NKN they have given us a Juniper router. For this, on this side they have a Cisco router. All these routers were the connection, the LAN connection of this router, launch, terminated in this firewall, that is FortiGate firewall. Using this FortiGate firewall, we splitted our network to different subnets. We had one, two, three, four, five, six, seven. This much of subnets are there. That is, one is 0.1. Then we choose 172.16.00/22 as our network. This one network. This then /22. That was a subnet mask. Then we have 172.16.4.0/22 for this network. Then 8.0//22. Then 12.0, 16.0, 20.0, 24.0, 28.0. Likewise, it's got. We have split it into different subnet. Our LAN was split. So this is our network. Okay. So let us see what is a router. So this is a typical router we installed in the gateway. So in the router we have router means it route the packets. It have one or more WAN IP and one or more LAN IP. The WAN IP, this is the BSNL side WAN IP. We have 172.24.66.78 on the WAN side. And for the LAN side, we have this one, 102.1.2.30. And this is a typical Cisco router installed in our campus. And this is a typical Juniper router in our campus. This is Juniper, and the LAN network is this one. WAN is this. Then this is the power gateway. That is again a Cisco router. The LAN IP is 114.132.189.129, and WAN IP is this one. Okay. And this is our firewall, our firewall, and you know that in the firewall we have different types of networks. These are the networks, UTP ports. This is a WAN one, this WAN two, this everything, this one. And for example, I'll show that this WAN one is our NKN connection, or WAN one is our BSNL connection. So that BSNL Cisco is connected to this port, and Juniper connection was connected to this one. Polymer Science was connected to this one, and we have a DMZ zone. We have the first subnet 172.16.0.0. We have this 172.16.4.0. Likewise, this firewall is connected. And below this firewall, we have core switch. Core switch we have installed in our main center, that is computer center. Then we have in the physics department. Then we have one more in the lakeside department. Everything is managed using this IP address. So this is a typical core switch. And core switch is we have a chassis based core switch. So these ports we can choose it as either we can connect using a fiber cable, or you can use a UGP cable. That depends on us. We have to purchase the module for that. That's all. This is a computer center, and this is the physics department. Again, the same make. That is this one SG550XG24. This is the model of this Cisco core switch. And below this core switch, we have distribution switches. These distribution switches are hosted on each hub of each department. So the network is 192. So from sitting on the computer center, we can manage this part. These are the manageable switch against. So this is our internet zone. So this is a typical, as I told you, this is the 1 Gbps connection, and the connection speed is on demand, as I told, and we have the IP ranges from this one. 14 usable hosts are the public IP address. Then we had a one, not 150, we have 250 Mbps line for the one BSNL, 1:1, and the band the IP address ranges from here. 50 Mbps line to Marine Science campus, 40 Mbps line supporting in the campus, and we had one more one, 100 Mbps to power grid from the and the public IP addresses like this, right? This is our internet zone. And for the demilitarized zone, we use 10.0.0/16 as our network, and all our mail server, all our web servers, proxy servers, firewall, DNS, everything is have this IP address, and all the servers is mapped to this external IP also. So you get it viewed from the public. And this is a network address translation, typical network address translation. As I told, 10.0.0 is a DMZ zone, and this is a map to an external IP. And people outside CUSAT will be seeing this IP address. And from after getting the firewall, it will be mapped to this one. So mapping can be done. A firewall policy can be done between these two. So ports can be filtered, ports can be blocked, everything can be placed here. That policy can be placed between this NATing. And this is our militarized zone, that is our local area network, that is 172.16.0 road. It's like this. This is splitted, and administrative office, library, computer center uses this ranges. Then the this 4.0 up to 7.255 254 used by these departments. Likewise, it is split. That is our local area network. It is continued. And a DHCP server is installed to release the IP address. DHCP means Dynamic Host Configuration Protocol. So before, users no need to configure their IP address manually. Okay. And okay, this is a typical DHCP server. For this range, it's last of the two was taken as a DHCP server for each network. So this is a typical DHCP server configuration. Likewise, this is a Linux-based DHCP server, and the configuration is like that. This subnet is specified here, at least time, and the range is specified here. What it is? Insert domain name range. See, this range 4.100 to 6.254. This range, not just 6, just 7. This mistaken. And the website, we have a website CUSAT.ac.in, and all the subdomains are here. We also purchase the SSL certificate, those star.cusat.ac.in, and everything is hosted in our campus itself. Everything are all our servers runs under open source platform. We had a, virtual machine also. And then the domain system, we host our own domain system. This is a typical DNS expert. This I have another slide. This DNS and the configuration, everything is explained in my another slide for DNS. So I'm just skipping this one. So this is a internal. We have a two DNS server. One is the internal DNS and the external DNS. For internal communication, we use this 10.0.0.2 as a DNS server, internal DNS server, and these are the configuration. So that configuration, everything I have explained in my other slide for the DNS. This is our external server 210.212.233.36. Okay, so this is a website configuration. So for the website, we use um, this one, Apache as our web server. So I'll take a break for that. This is, excuse me. Okay, welcome back. Um, so I would like to say something about the website configuration. So as I told, the Linux servers were used to configure all the servers. So for the website also, we used Apache as well as Nginx to configure websites. So all the web servers is in the DMZ zone. So if a database is needed for our website, we use the MySQL as a database, and some servers were running PHP. Some server are using Django. Some are using PHP, Python. All open source flavors we have. Then we use SSL. We give SSL service to users to upload their websites. And okay, we don't recommend this content management system like Joomla or WordPress like that. Even they are using. So for Apache configuration, we use Ubuntu 16.0 for LTS, and now it has 18.04 was launched here. And for DNS configuration, we use the bind. And this is a typical Apache configuration. If we have finance.cusat.ac.in, an Apache server is configured like this. Then we have, after configuring a website like that, we have to give the supply that term in the DNS server, that is in the 10.0.0.2. So like this, DNS entry is like this, and a resource record to be written like this. And also for external DNS to get the public access, we have to specify, we have to add a record like this, finance record. CNAME is a canonical name. So finance.cusat.ac.in will be mapped to 14 like this, 14.139.180.5.29. And this is a firewall in FortiGate. So FortiGate is the FortiGate for this mapping NATing. The NATing is done in this firewall. And it is like this, a static root for a firewall. This is a firewall, typical firewall configuration. Firewall, we have to install. We have to supply an IP address for each port. Each port is configured like this. Then like this, we have interfaces are configured, and each port has its own LAN number, and these are the ports. These are the protocol used allowed in this network in this particular port. So to manage, we can use SSL, we can use HTTPS, you can use HTTP also. And this is a static route. Static route means this is the first route. That is, all the users will be going out through this network. That is a WAN one. Then, if this one is failed, this is a round robin. So if this one fails, this will be takeover. This is the primary, the secondary, and the tertiary. And this is the third one. So this is installed in the polymer sense, right? And this is the policy routes. Policy routes means we can specify which path the network packet has to go out. By default, as I told you, it will be choosing WAN 1. If we want to it go to WAN 2, we can specify links. Before um, it's a orderly first the first after first one it will take only the second one. So this you can see that from port 4 to for going outside, he'll be choosing the outgoing interface as WAN 2, that is NK. Then, as I told, by default it is WAN 2, but we can change the priority lines. Then this is the network address translation, that is NAT. So this DMZ DMZ IP address is mapped to a public IP address. So likewise, this is done in the firewall. And we use firewall as 600 FortiGate firewall 600C. And these are the subnets. CC1 network, we have given a name like this. This is a network. And these are the services. The services, what all ports has to be opened, we had to specify. So we gave some port numbers. These are some common ports, HTTPS. These are some common ports, but this port we can customize this port like this, and this can be implemented to uh, enable it. So this is a typical IPv4 policy. This DNS server, this is some name, this is a network, incoming network, this is the outgoing network, and this is a schedule how when it has to go. And these are some services that I told you. So we can enable the port numbers here, so we can specify whether accept or deny like this. So this is a typical IPv4 policy defined in the firewall. And also we have an LDAP server. All LDAP server means it's a lightweight directory access protocol. So using LDAP, we can have a common authentication system. So 10.0.0.12, this server was used as CUSAT LDP and LDAP server, and the distinguish DN name is right. It's an LDAP configuration. The port used is 389. So for the time being, we use the Wi-Fi connection are also implemented here. So Wi-Fi access points are here. We have FortiGate firewall. For the FortiGate firewall, we have FortiGate Wi-Fi also. So that this firewall is act as a controller for this Wi-Fi access point. So from one point we can control all the Wi-Fi. That's we have installed some 60 Wi-Fi connection throughout the campus. From sitting in the computer center itself, we can control all the Wi-Fi access points using some interface, right? So that is managed using this same firewall, right? So this is a typical, and you can see that this firewall has an LDAP authentication. So that user, all the LDAP user, that is people having an email address like at CUSAT.ac.in can access the Wi-Fi connection. So this is a typical Wi-Fi supplied IP address. Okay. So this LDAP user, group is LDAP user, and this man has logged in this time, and also date was also given there. Okay. So we can see monitor the Wi-Fi access. It's a monitoring of Wi-Fi access. You can see the source and destination, and which port, which source interface here it is chosen, and destination here, and which port it is used. So we can see the IP address of a user here, and where destination of the user, where site is going, and which port he is using, and how many bytes he has used. This one, likewise, we can monitor the firewall. Okay. And security monitoring, web filtering is also provided in the firewall. We can block some malicious websites. We can customize our network access like this. We can block, say, spam URLs, phishing server, malicious websites, peer-to-peer sharing. We can enable this like this by using a tick command. We can enable these things. And of course, we can block this other mature content like this. That is also implemented in the policy. Some application filtering, some certain application we can block some social media, some proxy server, some botnet. Everything can be blocked like this. Peer-to-peer network can also be blocked. And we had one more server, that is the 40 web. 40 web will be, we can monitor the events, whether an SQL injection is taken place, and something, if something like that anti-spam, everything can be monitored in a device known as O40 web. That also implemented in the campus. This is a typical portrait web monitoring. And in this time, we can see that an SQL injection attack was detected. That is, a source is 10.0.0.1 and destination is 10. So this 10.0.0.59 had some SQL injection attack. So we can monitor this, and we can and also you can see that which PHP file is affected. So we can monitor, and we can get some solution for it. And it is an attacks analyzed like this. There's feedback, captcha. These are some attacks. So we can modify our model, our code. And this is some policy given for this in this 40 web. And at address pool. So in the address pool, this means that one IP address can be shared with, say, suppose we have three or more machine, very typical machine. For during the admission procedure, we had say, large heat, so we maintain our admission servers in different typical, say, two or three servers, and above that we people see only one IP address, and the IP address is mapped like this. So this is done in this address pool of 40 web. And also it is about the 40 web. And this is bandwidth monitoring. So we use a multi-router traffic graph, or MRTG, to monitor the network. This is a simple thing. This is a commonly used network monitoring system. So for this, you can see the traffic load in this particular, or each network can be monitored. So for this, we need to enable the SNMP service. Okay, this is a MRTG network. This is a typical, so you can see the bandwidth, bits per second here. This is time, this increases. So you can see that from this is 8 o'clock, 10 o'clock, 12 o'clock, the peak time, 2 o'clock, and between 2 and 40, there's a 1 o'clock, it's at the maximum peak time. Then here also, it's a maximum peak time, that is up to 100 Mbps. Likewise, we can monitor using the this is pulling on this Lakeside campus. Okay, so in our campus we have used active components and the passive components. Active components means, what is an active component? Some switches, hubs, switches, media converters, everything which needs a power to operate. It is known as active components. We have active components. We have passive components like this. We have multi-mode, single mode. This don't require any power to operate. So multi-mode ST connect, straight chip connection, which was used earlier. Then SC, square connectors. Then loosened connectors, LC, and FC connection, femule connections. That is ferrule connection connectors. That is used FC connector. We are not using this one. So that's why I'm familiar with this one. So LC connectors, we use LC connectors. Nowadays we are using LC connector. See, these are the some connectors. LC connector is like this. SC connector is like this. FC connector, this one, and the ST connector, this is the old one. And this is a straight source is straight. For the multi mode, the images goes like this. For single mode, image goes like this. So for multi mode, there will be some interruptions like this. For single mode, it's going straight. So, and these are our hub racks installed in the different departments. This is a typical department network, right? Then this is the media converters. Media converters means the UTP connection is converted to the optical connection. Media converters. And this is our final network. So this from this we I think I have discussed deep, only a brief discussion was this about our Cochin University campus. Hope you enjoyed my presentation. So this is what I am familiar with. So I think it will help you to configure a campus. If you have any doubts or uh, any information for me to pass on to me, just mail me or just call me. So thank you very much for patiently listening. This one for a long discussion like this. Thank you.